Hello, everybody, and welcome to another series in our 2018 Washington State Energy Code Commercial Training Series. Today's topic is envelope alterations in existing buildings. My name is Dwayne Llewellyn, and I'll be your presenter today. Let me introduce you to the Washington State Energy Code Commercial Technical Support Team. My name is Dwayne Llewellyn. Been involved with Energy Code training and technical support now for about 9 code cycles or so. Our team is headed up by Lisa Rosenau. Many of you have spoken to Lisa. She heads up our web support tools. And then also Chris Haas, who is our resident electrical engineer and helps us out on the electrical and the lighting side. We provide on-call technical support through 3 avenues. We have a telephone hotline, so you can reach out to us at 360-539-5300. You can also reach us through our online webpage, which is waenergycodes.com. There's a method for reaching out to us via email there, or you can email us directly at com.techsupport@waenergycodes.com. In addition to the technical support, we provide classroom and webinar training, such as this event, this on-demand training that we're doing today. And we also administer the new technical support and compliance documentation web tool. So a little bit about codes. We want to reach out and thank the Northwest Energy Efficiency Alliance, which provides the funding for the training and the support for codes, not only in Washington State, throughout the region, including Idaho, Montana, Oregon, and Washington. So if you're doing work in those states, you can go to the Northwest Energy Alliance, look at their energy code support, and reach out to those folks that are providing similar support services to what we do here in Washington State. So once again, thank you to NEA for sponsoring this training. We've had quite a series here for 2018 online training. The first 7 episodes we presented were back in 2020, before the code went into effect. These webinars are available for your viewing pleasure through our website to view at any time. And then this fall, we started a training series focusing in on existing building operations and upgrades. So episode 8 was on mechanical and service water heating in November. Episode 9, lighting and electrical systems, in December of last year. And then, of course, today's Episode 10, Envelope Upgrades, February 17th, 2022. And I'm sure we'll be doing some more training here throughout 2022. So become a member of our website and you'll be notified of upcoming training opportunities. If you don't have a copy of the Energy Code, I always try to get people the first place to start to actually download the document. And you can download for free at no charge copies of both the commercial code and the residential code from the Washington State Building Code Council website. You want to make sure you download the second printing of the commercial code. As many of you are aware, this code was originally set to go into effect in 2020. It was delayed to the fall of 2020 and then delayed again until February 1st of 2021. So the 2018 code has been in effect since February 1st of 2021. Also, it's worth noting that even though we're talking about the commercial code, it does apply to residential buildings 4 stories or greater, or in other words, greater than 3 stories. And so if you're working on mixed-use projects or R2 projects, 4 stories or greater, they are regulated and governed by the Commercial Energy Code. Also, our disclaimer is that this presentation reflects our unofficial interpretation of code intent. We do not have any authority. Our support team is not an affiliate, nor do we speak for the Washington State Building Code Council. This is technical support that we provide as a service to permit applicants and is advisory only and non-binding. Now, the State Building Code Council does issue official opinions when requested by a building official. And there's already been about a half dozen opinions that have been issued for the code. So often if you call us, we will refer to one of these opinions. You can go to the State Building Code Council There's been opinions issued about total performance total system performance ratio, total building performance, DOAS requirements, data centers, and additional efficiency credit options. And so we use those opinions when we help answer your calls. You can get a link to those opinions through our website, or you can go directly to the State Building Code Council. We've got a busy schedule today. We're going to kind of breeze through this quickly. We could probably spend all day talking about envelope alterations, but we're gonna try to cover roof and ceiling alterations for you, wall and floor alterations, building entries and vestibules, fenestration, which is a fancy word for windows and doors, essentially a hole in the envelope, including window to wall ratio and skylight to roof ratio. Changes in space conditioning or occupancy, building additions, repairs, historic buildings, and of course at the end we'll cover our envelope web tool. I also want to say that we should be wrapping up in about 50 minutes or so, and there will be a live Q&A session. So if you have questions, or if questions come up during the presentation, please use the Q&A portion of the app that you're using to list those questions. Lisa will be monitoring that, and then we'll moderate a live Q&A at the end of the session. You can use the chat function too, but try to keep all your questions on the question Q&A function. Also, you can upvote a question. So if somebody asks a question and you're also interested in that, you can upvote that, because we'll sort the questions by who gets the most votes, and we'll see how many we can get through here in our allotted time today. So with that, we'll go ahead and dive into roof and ceiling insulation. One of the important things to keep in mind is definitions. You know, if you're in doubt, you're not quite sure what, look for the codes and definitions. And when it comes to especially roofs, there are several definitions in the code that will have a bearing on compliance. Now, anytime a word is a defined term in the code, it's in italics. So if you're looking through the code, either electronic version or a printed version, and there is a word or a term that's in italics, that means it's defined. Now, it may not be defined exactly in the energy code. It may be in the IBC, the IMC. But this is important when we start talking about roofs. So there's some specific definitions for roofs in the IBC. And then there's a couple of definitions in the Washington State Energy Code. And so if you're looking at what do I got to do for insulation based on the scope of work, you're primarily looking at in the WSEC roof recover and roof replacement. We'll go through each one of those. But again, it's important, and it's not just limited to roofs, it's limited to any portion of the code. Again, if a term is in italics, it's defined in Chapter 2 of the Energy Code or Chapter 2 of the IBC. So if there's a question about what they're referring to, pay attention to those definitions. So re-roofing, from the Washington State Energy Code process or definition of roof recover is the process of installing an additional roof covering over an existing roof covering without removing the existing roof covering. So you're hot mopping, or you're laying a new single ply roof over existing, you're putting another layer of shingles over a roof. In this case, you're not exposing any roof insulation, so it can remain regardless of the insulation, not required to be brought up to the code. So you can re-roof a building, putting another layer over without having to bring that roof insulation assembly up to code requirements. Now, roof replacement, as far as the Washington State Energy Code is concerned, is the process of removing the existing roof cover, repairing any damaged substrate, and installing a new roof covering. So now we're going to remove the existing roof cover and potentially expose insulation. So what's going to drive the insulation requirements here, or the Energy Code requirements, is where does the insulation exist? What is the location of that existing insulation? If that insulation is entirely above the roof deck, we're going to cover that next. If it's below the roof deck, in between the roof joists or metal parts, then there's no effect on that. You're just re-roofing. You're not exposing the additional insulation. And the upgrade of above deck may be necessary where existing insulation is located above and below. So if you're replacing insulation on the roof deck, and there's also insulation down below, at a minimum, you're going to have to, now you've exposed that assembly and bring that up to standard. So we'll go into this hopefully with some examples and better details. So it really depends on where that assembly is insulated. The easy one to determine is where all of the existing insulation is entirely above the roof deck. So you're going to remove the existing covering, you're going to expose that insulation above the roof deck. You may have to replace some sheathing or replace some damaged insulation, but in these cases, that's an opportunity to bring the insulation values completely up to code. And that requirement is R38, continuous insulation, all the way out to the perimeter walls. The code requires that you use multiple layers of insulation and that you overlap the seams. And I mentioned that requirement is R38 continuous, or if you've got a unique assembly, the prescriptive U factor is 0.027, which is roughly R38 continuous. So that's an easy one. So if you're replacing the roofing, you expose the insulation below, maybe you have to replace some of that insulation, you shall bring that either existing insulation plus new or all new insulation up to R38. Now, when you do install insulation above the roof deck, there's a couple of methods. If you have a slope structure with a uniform thickness of insulation throughout, then it's simply R38. So you just need to make sure that you are a minimum of R38 insulation. Now, sometimes you have a flat structure with tapered insulation, so you're going to use insulation for your drainage slope, or you even have a slope structured with tapered insulation. So when you have tapered insulation, you obviously have minimum and maximum R factors in the assembly. And, you know, in the past, frankly, the code has been gray, how to calculate what that uniform, what that average U factor is, depending on your minimum insulation value and your maximum. So a couple of code cycles ago, we added a table to help you determine what those minimum and maximum U factors are, depending on the type of slope in the roof structure. And I'm going to reference those tables here now. Again, there's 3 tables depending on with insulation using tapered insulation installed entirely above the roof deck. The first one is just a single slope. So maybe you've got a peak and a slope off of that peak to the perimeter. And you can see that on the x-axis here we have the rated R value at the minimum condition, which may be at the perimeter edge or maybe a roof drain or scupper. And then you have at the x-axis here, or the y-axis, you have the R value at the maximum rated condition. So you can use this chart, and I've highlighted here the values that meet or exceed the code requirements. So, for example, if your minimum insulation value is R30, your maximum can be anywhere from R45 to 60. Any values below that, values that are not highlighted, do not meet the requirement for new construction of 0.027. So that's in a single slope, rectangular slope. We've got a tapered insulation for a slope triangle where the drainage is in the middle, so you're actually tapering from the perimeter to the center. Again, the same concept here. We've got the minimum here on the left side at the horizontal axis is the maximum, and those combinations will give you that. Again, those combinations are highlighted. And this is also if you're doing a trade-off calculation where you're using increased roof insulation to carry some other envelope deficiency. You can see that you can actually exceed the code requirements by having a lower U factor, and that'll help offset some other deficiency if you're using a component performance approach. Again, these are all vetted U factors, so when you're using tapered insulation, cite these tables as your source for the U factors that you're using. And then finally, same triangle roof configuration, except for now the drainage is at the perimeter. So the peak is in the middle, the minimum condition is at the perimeter. This can be common, especially if you've got parapet height issues and stuff and you're trying to minimize the thickness of insulation at your perimeter. Same concept, I've highlighted the acceptable combinations. So that's rigid board insulation entirely installed above the roof deck. Some other situations are where the insulation is not on the roof deck, it's installed below the roof deck within the structure. And so there's some rules that we can apply with alterations. First of all, if you're just repairing a ceiling, you're not exposing the entire structure, that's fine. You do not have to bring the roof ceiling up to code there. You can repair a structure. If part of a tenant improvement or modification or alteration, you expose roof structure. If that roof structure doesn't have any insulation in it, for example, in this example, it's insulation between the joists or rafters, or no insulation down below, then again, you're required to insulate. And that's just common sense. If you find, or if you have to remove insulation because it's damaged, you can simply remove that insulation and install new insulation within that existing cavity. You do not have to bring that up to total compliance. You're just repairing or replacing insulation for areas of the building that are exposed during the alteration. Now, if you do a tenant improvement and you are removing all of the ceiling, you're exposing all of the existing roof structure, then we believe the intent of the code is that you bring that structure up to compliance with the code. And so this is an opportunity to upgrade. If all the insulation is installed below the roof deck, you now have access to that assembly and you can bring that up. So this is frankly a judgment call where the entire roof structure is exposed. So you're doing a gut remodel, you're taking all the existing insulation out, you're exposing everything down to studs and framing, then obviously that would be an opportunity to meet the full code compliance, so that U factor of 0.027 or R38. And then finally, scenario 4, and we'll talk about changes in space conditioning or change of occupancy a little bit later, but when there is a change in space condition or occupancy that triggers full code compliance, then yes, you need to bring the project up to full compliance, including air barrier provision. So now you need to pay attention to the air barrier layer in your ceiling assembly. And then obviously it's impossible to try to review every situation, but some of the things that we see come up occasionally is where there's a combination of insulation installed both above and below the roof deck. And that's fine. The energy code doesn't prohibit that. You have to do a U factor calculation because there's no prescriptive path for compliance with that. There may be limits on how much rigid board you can put on the roof because of existing curbs or roof drains or sky. So you want to use some combination of rigid board insulation and insulation below within the framing. And that's fine. We do, that would be up to the jurisdiction approval. We do recommend that you do, there's some rules of thumb for doing that. The one thing we don't want is a situation where we have a cold surface. There's inadequate insulation above the roof deck. That roof sheathing is cold and we have a potential for condensation occurring because we're assuming a non-vented space in that cavity. There's the old rule of thumb is at least if you've got at least a third of the value at the roof, that will keep that roof deck, but we highly recommend that you do a dew point analysis and just ensure that the dew point isn't occurring at that roof sheathing level. The other situation that we run into is existing insulation on top of suspended ceilings. And believe it or not, this was allowed in the commercial energy code for many code cycles. Probably in the last 3 or 4 code cycles, it was prohibited. But previous to those, so if you got a building that was built, in the 90s or in the 2000s, it was common to have insulation above the ceiling. I mean, the bottom line is really that's a temporary situation. The insulation is easily disturbed and moved. If you're only affecting a small part of a ceiling in a space, that can remain. Again, if you're taking all the ceiling out and you're putting in all new ceiling, then you will need to relocate that insulation to another assembly. You can suspend it above the new T-bar ceiling, but if you touch it, you need to make sure you comply with the current standards. If you're doing a complete tenant improvement and removing the existing ceiling and putting in new ceiling, then you need to relocate that insulation either above the T-bar ceiling, so it's not directly on the T-bar, between the structure, on the roof if you're doing a roofing project. So keep that in mind. So, just as a summary to these roof alterations, the insulation requirements basically depend on the scale of the alteration. Is it a roof repair? Is it a roof recover? Is it a roof replacement? Or is it a brand new roof? So all those are going to determine what the insulation requirements. And then secondly, it also determines where the insulation is located. Is it all above the roof, all below the roof structure, or a combination of below and above the roof structure? And that will determine the requirements. In all cases, you want to make sure that you meet the venting requirements per IBC, and in no case shall the energy performance of the building after the alteration be less than it was before the alteration. So we don't want to go backwards. We at a minimum want to stay, if not improve the condition, because that's an opportunity. So, wall and floor alterations. So, same process, and going through these alterations. If it's just a repair, you're damaging some sheetrock, maybe there was a leaking pipe, then you're going to just re-insulate that area. If there was damaged insulation, you'll pull that out, re-insulate, and do the repair. You don't have to meet the full requirements of the code. You're probably not even getting a permit for that scope of work. If you're doing a tenant improvement and you're removing and you're exposing cavities, and those cavities are uninsulated, or you're removing insulation, then you do need to re-insulate those cavities, and that's just common sense. In an exterior wall, and we are talking about elements that are part of the envelope, not necessarily interior partition walls, whether you insulate those or not, they're not part of the envelope. Infill of the sectional wall after removing. So we've run into situations where you're removing some fenestration, windows or doors, and you're going to infill that with opaque wall assembly. We believe that the reasonable approach here would be the same rule as exposed cavity. So if it's a 3.5-inch cavity, you would insulate that with R3 per inch or better. That will maintain the planes of your wall assembly and improve the condition, because you're replacing, say, a window with a opaque wall, which has better thermal performance. Now, if you're exposing all your window or floor cavities, so it's an extensive gut remodel, plus you're infilling some of those windows, then we believe the intent is that you bring the entire assembly up to compliance, not only the infill area, but the adjacent wall assemblies. And so a lot of that's going to have to deal with scope of if you're planning, again, that gut remodel where you're removing everything, removing all the insulation from the framing and starting new, then we believe that you need to meet the current insulation requirements for your walls and floor cavities. Again, projects change of space conditioning or change of occupancy. This is our fifth scenario. Anytime that occurs, it's full compliance. So we'll define what that change in space conditioning or change of occupancy is a little bit later in the presentation. Now, re-siding. We've had some questions come up with, all we're going to do is remove the old siding and put new siding. Are there any energy code issues? Well, that depends on the location of the existing wall insulation. So if all the insulation is inboard of the siding, on the interior and the cavity, and you're not exposing that insulation, then there's no requirement. Now, if some of that insulation is exterior to the sheathing, so it's a combination of rigid board plus cavity, which we're seeing more and more in today's construction, and you're exposing that rigid board, if you're not replacing it or you're not removing it, then it can remain as is. If you're removing it because it's damaged, then you need to replace it with existing or better insulation values. If you're exposing the cavity as part of that, you're removing sheathing, siding, and exposing the cavity, and the cavity is uninsulated, or the wall insulation is damaged, so you're removing that. You need to fill that cavity, those same rules. But on that exterior, it's only if you're exposing that rigid board insulation that may be part of that assembly, you would need to replace that or leave it in place. Again, the rule of thumb, in no case shall we go backwards. We shall either maintain the performance or improve. So, similar to the roof discussion, wall alterations depends on the scale. Is it a repair? Are we residing? Are we doing a gut remodel? Are we exposing cavities? Again, it depends on the location of the insulation. Is it cavity only? Is it cavity plus exterior? Is it exterior only? And what is exposed? And as I've mentioned, the guiding principle here is that the performance of the building after the alteration shall be no less than the building prior to the alterations. And we believe that where there's only a section of the exterior or interior wall that's altered, it's reasonable to insulate that to the highest level feasible while maintaining the existing wall plane. This is that issue of infill, where you've got existing exterior materials, interior materials. You don't have the room to put in a 2x6 framing assembly and a combination of cavity and rigid board insulation. We believe that achieving the highest value that you can in that infill situation meets the intent of the code. So building entries. This is pretty simple, pretty straightforward. If you're replacing an existing entry door, so you're just replacing the door, the addition of a vestibule is not required. If you're making an alteration to an existing vestibule, then either the existing vestibule shall be maintained or replaced. So maybe you're relocating the entry and you're going to remove the vestibule for that entry, then you need to provide a vestibule in the new entry. So again, we don't want to go backwards. We want to maintain or improve. And again, if it's a new building entry, especially a public entry, then you need to provide a vestibule. Keep in mind there's a lot of exceptions for vestibules in the code. That's not a blanket statement that your entries always have to have a vestibule, but there are situations on where vestibules are required, especially on main public entries. And so if you have an alteration that's installing a new building entry, make sure you look and verify whether a vestibule is required. So windows and doors. There's some guiding principles when it comes to replacement, additions, or reductions in windows and doors. First guiding principle, all new fenestration has to comply with the requirements for new construction. So we have maximum U factors, maximum shading glass coefficient, and visible light transmission, especially in skylights. So any new glazing or fenestration, door or window, needs to meet the minimum code requirements. It is acceptable to use a weighted average within product categories. So a product category would be fixed glazing as opposed to operable, or glass doors. And you can do a weighted average U factor. So you can actually have some glazing that doesn't meet the U factor, but when you do a weighted average with all of the like product glazing, you comply. So you've got some windows that are above 0.30, some windows are less than 0.30. As long as your weighted average U factor is 0.30 or less, you're deemed to comply with the code. So that's acceptable. Another guiding principle is window to wall ratio and skylight to roof ratio. Our code requirements for glazing are determined on the for vertical fenestration on the window to wall ratio. Either 30% or less, or greater than 30%. Vertical includes windows, doors. Doors with more than 50% glazed area are windows, including garage doors with more than 50% glazed area, glass block, curtain walls. So those are all part of windows. For horizontal fenestration, skylights, the maximum is 5%. And a skylight is defined as a fenestration that's at a slope of less than 60%. So skylights, sunrooms, solariums, tubular daylighting devices, those were all part of that. So a key guiding principle is that window to wall ratio and skylight to roof ratio. And that needs to be determined to verify what the U factor requirements are. How you calculate those window to wall ratios is pretty straightforward. It's just the window to wall area divided by the gross above wall, or the window to wall area is the total gross above grade wall area and the total building gross roof area. And then you divide the glazing area into that total gross above wall area, and that gives you the percentage of glazing to wall or percentage of skylight to roof. Keep in mind that if you've got buildings with more than one space conditioning, say a semi-heated warehouse with fully conditioned office, those calculations are separate. You're going to calculate the window to wall ratio for the semi-heated independent of the office or separate. Same thing with your skylight to roof ratios. The other thing is interior partitions. So that interior partition wall between the warehouse, semi-heated warehouse, and the fully conditioned is not included in your calculations. Even if it has glazing in it, it's not included in the window to wall ratio calculations. So we're going to go through some scenarios, and hopefully you can follow on. There'll be a copy of this presentation that you can download for future reference, or you can. This is being recorded, so you'll be able to review this again at a later date. But scenario 1: replacement of existing fenestration. So you're just going to replace the existing windows. You're not changing the window to wall ratio. You're not changing the skylight to roof ratio, and so there's no additional compliance. You just got to meet that first guiding principle, the U factor, shading coefficient, and visible light transmittance for your skylights. Scenario number 2: removal of existing. So even if you're going to remove, and it reduces the window to wall ratio, so you're infilling, you're actually reducing the percentage of glass to wall area. Even if it's less than 30% or less than 5%, it reduces that down. No additional compliance. You just got to meet the basic U factor 0.30, shading coefficients depending on orientation. No additional hoops to go through. So again, that guiding principle, at a minimum, you've got to meet the minimum glazing performance factors. So what happens if you put in, you're adding windows, so you're actually increasing the window to wall ratio of the project? That's okay. So as long as the resulting window wall ratio after the alteration is equal to or less than 30%, or the skylight to roof ratio after the alteration is less than 5%, no additional requirements. You just need to meet, again, the minimum prescriptive value. You're less than, think about it as new construction. You would be less than 30%. No additional requirements apply. So even if you're adding new windows, as long as you stay under that 30% or 5% threshold, there's no additional requirements. Now, what happens if you add new fenestration and the resulting window to wall ratio is greater than 30%, or the skylight to window ratio is greater than 5%? Then you've got to meet some additional efficiency requirements. And here's what they are. So if that new glazing, if you're adding new glazing and it exceeds that 30% threshold, there's some options. You could use the high performance U factor and solar heat gain coefficient. So you can use a better U factor, better performing window to offset over 30%. And there's no high limit on that. It's just that if you're over 30%, you've got some additional requirements. You could install daylighting controls. So you could stick with your 0.30, but as part of your fenestration project, because you're adding glazing, you can install daylighting controls for that new vertical glazing only, not necessarily for the existing, just for the new. Or you could trade off that U factor deficiency with some unaltered. So maybe you're adding some new windows, but you're also doing a roof project, so you can exceed the roof insulation. You do a UA calculation, and that helps carry the deficiency for your glazing. So you can do a trade-off calculation in the existing building Essentially, you do a heat loss calculation and show that the deficiency in the glazing is being made up by additions of insulation and other opaque areas. You could do an energy model for the building and show that your proposed design is total carbon emissions is can be up to, and you get 10% grace. I didn't mention that in the UA when you've got an existing building alteration. You're allowed to exceed the target by up to 10%. And then additional envelope upgrades, so it does not reduce overall. That's code approval. That's kind of working it out with the jurisdiction, saying that in lieu of, we're adding some windows, we're exceeding, we're going to do some other, we're going to increase the roof insulation, but that requires code official approval. So, the code's not trying to limit alternative means and methods there. The ultimate guiding principle is we don't want to go any worse than what we had, and we want to meet the code at a minimum. So on the skylight side, it's the same thing. We can do a UA calculation and make up for that deficit by increasing other roof insulation or other areas, better windows. We can do an energy model for the project. Or again, we can work out a deal with the building official so that we're not reducing the overall efficiency of the building. And when you do those UA, when you're doing those trade-off calculations, you want to make sure that that the U factor calculations are documented. If you're upgrading roofs, or you're assuming that the roof insulation, have some documentation. Where are you getting those U factors? Here's the cut sheets and performance data for my new glazing. So here documents the U factor and solar heat gain coefficients. Here's documentation of my existing wall conditions, or my proposed wall, my existing roof, or proposed wall roof insulation. So you just want to make sure that your assumptions in doing these trade-off calculations are well documented. So we've mentioned change of space condition or occupancy, so we need to define that. A change in space conditioning is when a space is converted from low energy to semi-heated or conditioned space, or space is converted from semi-heated to conditioned space. So these are examples where we're adding heating or adding any amount of a cooling to a space that was either semi-heated or low energy before. So we're changing the space conditioning. Change of occupancy is fairly narrowly defined. Space is converted from group F, S, or U to something other than F, S, or U. Or space converted from group R to another use. So a residence, single-family residence that's converted to a group B office, for example. Or a group R dwelling unit converted to a commercial use if it was permitted prior to 2002. That would also trigger a change of space conditioning or change of occupancy. So if you have those conditions, here's an example: semi-heated warehouse enclosed to a fully conditioned office space, converted to retail, school building converted to apartments, single-family home converted to salon. These are all examples of where there would be a change in conditioning or a change in occupancy. When you have those conditions, space conditioning, occupancy, all disciplines shall be brought up to full compliance. So you just triggered the full meal deal for the code, including the envelope. So now it's going to be treated. There is that 10% grace that we mentioned earlier. So your envelope, recognizing that sometimes, for example, slab edge insulation, it's expensive and difficult to excavate around the exterior of the building to retrofit slab insulation, for example. So you are allowed this 10% grace within the target values, but you have to meet the full insulation package and you have to do air barrier testing. In your compliance options there for yours is you can comply as a standalone. So let's just say that your semi-heated warehouse, you're going to convert that to conditioned. It's part of a larger project, but it's just the warehouse area. Then you can just document compliance for that alteration as a standalone building. Or you can combine that with the remaining areas So, for example, your window to wall ratio calculations, now you're converting the entire building to a fully conditioned space. So they're all the one space category. So you can recalculate your window to wall ratios, and maybe that drops now below 30%. So that doesn't trigger the additional requirements for your glazing. So you've got some options here on whether you consider that alteration, that change in space conditioning or use as a standalone project within a larger building, or include the entire building in your code compliance. You can do prescriptively, you can do it as a standalone operation, you can do a UA trade-off, you can do the UA as a standalone, you can combine the UA with the alteration and existing, or you can do a full energy model for the whole building. So there's some options there on how you can demonstrate compliance when there's a change of space conditioning or occupancy as defined by the code. A change from group B to group M does not trigger full code compliance. I get this question a lot because we throw around the terms change of occupancy, but it's only F, S, or U converted to other than F, S, or U. Additions. This is simple. The addition can comply as a standalone project, so you would treat it as new construction, or you can comply with the addition plus the existing building to remain. This may come in handy if your addition has a lot of glazing, so your window to wall ratio of your addition is greater than 30%. But when you combine it with the unaltered portion, it drops below 30%. That will reduce the glazing requirements on your building. Or you can do a UA trade-off calculation to carry some deficiency in your addition. And again, the same thing, you can do comply prescriptively. You can do a UA calculation for the addition alone. You can do a UA calculation for the addition plus the unaltered, or you can do an energy model. Repairs. There is a section on repairs in the code. Sometimes I refer folks to that are kind of, probably the most common one I get is replacing lamps and fixtures. Do I got to comply with the code? No, that's generally considered maintenance. So the same thing on building repairs, broken windows or damaged walls. So, ordinary repairs and upgrades are not subject to energy code requirements, and this would include glass-only replacement, an existing sash and frame, just has to match the existing wall siding replacements without exposing that insulation or removing any exterior insulation. Roof repairs we talked about, applying window films to reduce solar gain. You don't have to meet the solar heat gain coefficients for code. Storm windows installed over existing fenestration, so maybe you've got a historic building, you don't want to destroy the nature of the building. Storm windows are a common approach there. Upgrades where existing roof wall or cavities are not exposed, so there's not an opportunity to upgrade or replace insulation. Those are all considered repairs. You do not have to fully comply. Historic buildings. There is a section in the code about historic buildings. It's very well defined. Is it on a historic register? Is it eligible to be on a historic register or listed? Is it in a historical district? Is it registered with the state historical preservation officer? So there's some background. So before you dive into that, you want to see if your building qualifies as a historic building. And there's specific language in there where the jurisdiction may accept alternate provisions or additional strategies to achieve a reasonable level of improved energy efficiency. So the code recognizes that when we're working with older historic buildings and we want to maintain that exposed brick construction on the inside, we could be limited on what we can do from an upgrade standpoint, especially buildings that have been unoccupied and maybe unconditioned for many years and now are being renovated and rehabilitated. It can be difficult to meet the full code requirements. So there is language in there that the jurisdiction may accept alternate strategies that achieve a reasonable level of improved energy efficiency. We don't want to go backwards. Historic buildings can be efficient buildings. So that's something where you reach out, pre-app meeting with the jurisdiction, provide as much information as possible about the status of the building in terms of its historic status, what your proposed improvements are, how are you improving the energy efficiency of the building. What are areas that you're struggling with in meeting that? Are there other forms of reasonable accommodation you're going to put in? You're going to offset some of that through solar renewable energy on site, other alternative opportunities for high performance strategies. A building model would be another one to offset some of those deficiencies. So you're just going to want to be upfront early on in the design phase with your jurisdiction with as much information on how you can meet the intent of the code. So the last section here, that concludes our talking about insulation and fenestration. We do have this compliance documentation tool that will help you document compliance when there are alterations, either replacing windows, adding window area, reducing window area, modifying walls, re-roofing of roofs. So those can all be accommodated in our compliance tool. As many of you are aware, for the 2018 code cycle, we've sunset, we've retired the Excel forms, and we've gone to an online compliance tool located at www.waenergycodes.com. This tool resides on the cloud. It doesn't reside on your computer. You're able to complete your forms online, store all your project information, which means that in the future, if there's a change in the project, you can come back and update your forms on there. You can have as many projects as you needed in there. There's no limit of the projects, and the cost is free. So the price is right, but you do need to create an account. So I'm hoping for those that don't have an account, you can create an account, because this is how you're going to document those alterations to your existing envelope. And it supports commercial, and it also supports a group R, so those R2 over 3 stories if you're doing alterations or renovations, mixed use and low-rise mixed use. It supports all levels of space conditioning, fully conditioned, semi-heated, and refrigerated spaces, which we really haven't talked to about alterations to refrigerated spaces. Reach out to me on a hotline, and we can talk through refrigerated spaces. There's unique insulation requirements there, especially if you're making modification. It also supports new construction, including additions, tenant build-out. If it's the initial tenant build-out or first tenant build-out, we treat that as new constructions. It also will handle changes, alterations, changes in space conditioning, or occupancy. So we hope that the tool will handle all those situations that you may come up with when you're dealing with existing buildings. We've also included what's called the envelope code requirements list. This replaces the checklist for those that are familiar with the prior Excel-based forms. But this way you can electronically complete the form and then download and print that, or you can just generate a blank list and hand fill it out. It's a really good quality control tool to make sure that all of the requirements are covered on your documents. And then finally, kind of the heart of the tool is our Envelope Smart Console. This is where you would define the buildings, alterations, new buildings, additions, change of occupancy. Then you then go through each assembly to define what your proposed requirement is. If you don't comply, then you get a red dot and say not in compliance, so rather prescriptive, and you have to use the UA calculation. But ultimately, if the project's in compliance with the code, you'll get a nice message that says it does comply, and you'll be able to generate then a compliance summary report. And this is what is submitted to the jurisdiction. And this report is required for not only new construction and additions, but alterations to existing buildings, changes in space conditioning, changes in occupancy, re-roofing projects, all of those situations that we went through today. And so this is the form. You can download and print this form. You can save it electronically. You can attach your calculations or supporting documentation when you submit it to the jurisdictions. But this is what the jurisdiction is looking for your project, and that it clearly shows that the space complies with the code. Okay, that concludes our presentation. We're going to be shifting gears here in about a minute or so and going to a live Q&A section. So hopefully if you had some questions, you used our Q&A feature in the app, and Lisa and I will be joining you shortly.